In this section, we will learn object-oriented programming and its implementations. First, we will learn fundamental subjects of object-oriented programming, inheritance. Then we will learn method overriding. Then we will learn how to use super and this as keywords. Then we'll play around with how to use the final keyword. And then we're going to learn abstract classes. And then we will learn interfaces. And then we will learn polymorphism, which is not a religion. Then we will learn encapsulation. Inheritance. So inheritance is a fundamental concept of object-oriented programming. It's used when we have a is-a relationship between objects. In Java, all classes can inherit variables and methods from another class. Inheritance enables us to reuse existing code. So in our example, we have a superclass, vehicle. All vehicles have a type, model, and max speed. Also, all vehicles can start and stop, right? So this is the base class. Also, we have two classes that are named car and motorcycle. So the car and motorcycle classes are subclasses of vehicle. So we can use the extends keyword by the subclass to inherit the features of the superclass. So the car and motorcycle classes inherit variables and methods from the vehicle class. And there's no need to declare these variables or methods again for the car and motorcycle classes. The car class has its own variable that's named isAutomatic. And the motorcycle class has its own variable that is named motorType. So in the object-oriented programming project, just right-click on the source folder and select New Class. Specify the package name as Inheritance and the class name as Vehicle. So now let's start to write a program that prints the properties of subclasses by using inheritance. The vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with string type, and the variable max speed with int type. Now let's declare a void type method, print, to display the values of type, model, and the max speed variables. And we'll use the print methods. So finally, we'll save that code. Okay, so now let's start to declare subclasses. Okay, so let's create a new subclass. Just right-click on the inheritance package and select New Class. Specify the class name as car. Now, in order to implement inheritance, we have to add the extends keyword after the subclass car. So our subclass car extends the superclass vehicle, and this just means that the subclass car inherits the print method and the variables from the superclass vehicle. So don't forget to save the code. Now, let's create another subclass. Right-click on the inheritance package and select New Class. Now specify the class name as motorcycle, our subclass motorcycle, extends the superclass vehicle. So this means that the subclass motorcycle inherits the print method and the variables from the superclass vehicle. And the motorcycle class is empty. And then finally, we can save the code. All right, so let's now create a new class for testing inheritance. So just right-click on the inheritance package and select New Class. Specify the class name as Inheritance Test, and then select the checkbox to add to the main method. So now, let's start to create a new car object. If you write car object and a dot operator, then you will see the variables max speed, model, and type, and the print method coming from the superclass vehicle. So let's assign car as a value to the type variable, Ferrari as the value to the model variable, and then add the value 320 to the max speed variable. Now let's call the print method from the superclass vehicle. Okay, so now let's run the code, and there you see the results in the console. Type is car, model is Ferrari, and the max speed is 320. All of these properties are inherited from the superclass vehicle. Perfect. So let's start to create a new motorcycle object, shall we? So you see the same properties and methods coming from the superclass vehicle. So let's assign motorcycle as the value to the type variable, Kawasaki as a value to model variable, and the value 180 to the max speed variable. And now let's call the print method from the superclass vehicle. Okay, so let's run the code, and you see the results right here in the console. Type, motorcycle, model, Kawasaki, and max speed 180. Excellent, excellent. Method overriding. So if you define a method in a subclass that is already defined in the superclass with the same name, same parameter, and the same return type, that is known as method overriding. So in this case, the method in the superclass is called an overridden method, and the method in the subclass is called the overriding method. So let's just do a simple example to understand it better. So let's say we have two classes, right? A superclass vehicle and a subclass car. The car class extends the vehicle class. Now, both of the two classes have a common method, right? The void stop. The car class gives its characteristic to the stop method. So it overrides the stop method. It prints the car has stopped instead of vehicle has stopped. Got it? Cool. Let's do up some examples so that you can play along with me and understand the benefits of method overriding. So in the object-oriented programming project, just right-click on the source folder and select New and Class. Specify a package name as method overriding and the class name as vehicle. Now, vehicle is our superclass. And then let's declare 3 public void methods in the vehicle class. First one is public void start. We print the vehicle has started message using the print method. And then the second one is public void accelerate. So this method takes one parameter that's named speed. And then we can print vehicle accelerates according to given speed. And then we use the speed variable in the print method. And then the last method is stop. In the stop method, we print vehicle has stopped as our message by using the print method. Okay, so remember to save the code. Right. Now let's create a new subclass. So just right-click on the method overriding package and select New Class. Specify class name as car. And in order to implement the method overriding, we have to add extends as our keyword after subclass car. Now our subclass car extends the superclass vehicle. So this means that subclass car inherits all the methods from the superclass vehicle. And the car class is empty now. So the question is, why do we need this method overriding? What we'll do here is let's create a main test class that we'll name override test in the same package. So in the main method, we create a vehicle object. First, we call the start method from the vehicle class. And then we call the accelerate method by passing the value of 80 of speed as a parameter. And then the last we'll call the stop method. Okay, so let's run the code. So you see the results in the console. Yeah? The vehicle has started, vehicle accelerates at a speed of 80, and the vehicle has stopped. Now let's create a car object to test. And we call the start method and then call the accelerate method by passing the speed value of 100 as a parameter and then call the stop method. Okay, so let's run the code. And you see the same results. The vehicle has started. Vehicle accelerates at a speed of 100 and the vehicle has stopped. But now, do you see it? There is a problem. We wait on properties of car, not vehicle in the second part. So we need to override the methods of the superclass vehicle in the subclass car. So let's override these methods and you'll see what I mean. Open the car class. Now let's copy the methods of the superclass vehicle and let's make the changes for implementing the properties of the car class. So we print car has started in the start method instead of vehicle. And we print car accelerates according to given speed instead of vehicle. And then we print the car has stopped in the stop method instead of vehicle. So you see what I'm doing here? These 3 methods have the same name, same parameter, and same return type with methods in the vehicle class. This is a rule for overriding. So remember to save the code. All right, so let's open the main class override test and let's run the code. And you see two different messages coming from the methods of classes. In the first part, we display messages from the superclass vehicle. In the second part, since we override the methods of the superclass vehicle in the class car, car has started, car accelerates at speed 100, and car has stopped are the messages that are displayed. So I hope that's clear as mud and you understand method overriding. It's very useful. Super and this keywords. Super is a keyword that's used to access the superclass members from the subclass. Super as a keyword gives us simple access to constructors, fields, and methods of the superclass. So in our example, subclass car class is using a super keyword to access stop method of the superclass vehicle, right? This keyword is used to access the same class members inside the same subclass. In our example, subclass car class is using this keyword to access its own start method. So we can also access other members of this class, such as variables and constructors, using similar methods. Let's see some examples of using the super and the this keyword. So we're going to open the object-oriented programming project by right-clicking on the source folder and then selecting New, Class, and then specify the package name as super this and the class name as vehicle. So the vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with a string type, and the variable max speed with int type. Let's declare a public constructor that's named vehicle, and we'll give it 3 parameters, type, model, and max speed. So in the constructor method, we can assign a parameter variable type to the variable type of this class. And we assign the parameter variable model to the variable model of this class. And then the last one, we'll assign a parameter variable max speed to the variable max speed of this class. So we use the this keyword to access the same class variables. So let's generate the public getter methods of these variables to access from the main method. Now, in order to generate getter methods, we can just right-click on the file and select Source, Generate Getters and Setters. And we choose Get Methods of all variables, and then click on the Generate button. And all selected getters methods will be generated automatically. And remember to save the code. Okay, so let's create a new subclass. So right-click on the super this package, and then select the new class. Specify the class name as car. Our subclass car extends the superclass vehicle. So this means that the subclass car inherits all the methods and variables from the superclass vehicle. Now look at this. We get a compilation error. So if you hover the mouse on the car class, Eclipse will show you a quick fix dialog, and we defined a constructor in the superclass vehicle. So now we must define an explicit constructor in the subclass car, and we must invoke the superclass constructor from this constructor by using the super keyword. So we can add a constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. Told you Eclipse was handy. So Eclipse automatically added the constructor with super as our keyword. Okay, so now in the class car, let's declare the variable is automatic with the Boolean type. So its initial value is false. And then we add the variable is automatic to the constructor of the car class as a fourth parameter. And then we assign a parameter variable is automatic to the variable is automatic of this class. Now, we need to generate a getter method again of the variable is automatic in order to access it from the main method, right? And I know you like to do this, so we generate the getter method of the variable using the same way we did before. See, you're getting the hang of it, huh? Remember to save the code. And let's create a main test class that's named superThisTest in the same package. Now, in the main method, we create a car object by passing parameters. The first parameter, car, represents type of car. Second parameter, Ferrari, represents model of car. The third parameter, 320, represents the max speed of car. And the last parameter, true, represents is automatic of that car. So we print the properties of the car class by using the print method. And in the first print method, we display the type of car and invoke the getType method from the superclass vehicle. In the second print method, we display the model of the car and invoke the getModel method from the superclass vehicle. And in the third print method, we display the max speed of the car and invoke the getMaxSpeed method from the superclass vehicle. Now in the last print method, we display the is car automatic or not. So we invoke the is automatic method from the subclass car. Great. So, okay, it looks great. So let's run the code. And you see the results right here in the console. Type is car, model is Ferrari, and the max speed is 320. And these properties come from the superclass vehicle. But car is automatic is true. That's right, because this property comes from the subclass car. Final keyword. It's not the final keyword, but it is final as a keyword. Now, as I hope that you remember, and I'm sure that you understood at the time, in the inheritance subject, the inheritance provides reusing existing codes, but sometimes we need to limit some of the properties for, well, many, many reasons. The final keyword allows us to do this. So think of it as a limiter. In this section, we will look at what the final keyword actually means for classes, methods, as well as variables. The final keyword can be implemented in class, methods, and variables. Final classes cannot be extended. So if we try to inherit from a final class, we get a compile error. Java core libraries have many final classes. Final methods cannot be overridden. So when we design a superclass and we want to make sure that the method in this class won't be overridden, we'll make this method final. Final variables cannot be altered. So we can initialize a final variable, but we cannot reassign a new value. So final variables are used to create constant variables. Okay, great. So let's do some examples so that we can both understand this a little bit better. Just kidding. So in the Object-Oriented Programming project, right-click on the source folder and select New, Class. Specify the package name as Final Keyword and the class name as Vehicle. Vehicle class is a superclass. Now let's declare an instance variable that's named Model with a string type in Vehicle class. And let's declare a void method, showMaxSpeed. And then we print max speed of vehicle is 180 as a message. How? Using the print method. And remember to save the code. Okay, so now we can create a new subclass. So right-click on the final keyword package and select New Class. Specify the class name as Car. So our subclass Car extends superclass Vehicle. So this means that the subclass Car inherits the showMaxSpeed method and the model variable from the superclass Vehicle. Now in the Car class, we can override the maxSpeed method of the superclass Vehicle. And we can print the message, max speed of car is 320, by using the print method. So remember to save the code. Now we want to limit some properties by using the final keyword. So let's open the vehicle class. For example, if we add the final keyword to a class definition of superclass vehicle, then save the code. So let's open the car class and see we get the compilation error. So let's look at it by just hovering your mouse over vehicle. And the error message is the type car cannot subclass the final class vehicle. So remember, final classes cannot be extended. I thought that sounded familiar somewhere. So we'll select Remove Final modifier of the vehicle class. And now let's open the vehicle class. And you see, Eclipse automatically removed the final keyword. For example, if we add the final keyword to a method definition of superclass vehicle and save the code, let's go ahead and open the car class, and we get a compilation error. So let's look at that. Placing the mouse over showMaxSpeed. Okay, so there's the error message. You cannot override the final method from vehicle. So, final methods cannot be overridden. You thought I was making this stuff up. So, we'll select Remove Final as a modifier vehicle dot showMaxSpeed method. and then save that code. So now let's create a main test class that's named Final Test in the same package. And in the main method, we create a car object. So first, let's open a vehicle class and add a final keyword to the variable model. Now we have to initialize this variable. So we just initialize the string with double quotes. And remember to save that code. Now let's open the main class again. So if we assign Ferrari as the value to our variable model, we get a compilation error. So let's look at that by hovering the mouse on the model variable. And the error message is the final field vehicle.model cannot be assigned. So final variables cannot be altered. So now we will select Remove Final Modifier of Model and save the code. Now let's call up Show Max Speed. Okay, so run the code. Now you see the result in the console. Overridden Show Max Speed method is invoked and it displays the max speed of the car is 320. Abstract classes. So an abstract class is used to implement common features of related classes. So it's declared with the abstract keyword. If a class has at least one abstract method, then the class must be declared abstract. Also, abstract classes may contain non-abstract methods and variables. You cannot instantiate an abstract class. That means that you cannot create the object of it. So in order to use abstract as a class, we have to inherit it from another class. So you can think of an abstract class as like a template. You must extend it and override the abstract methods. An abstract method is also just a prototype. So it has no body and contains the following attributes: a return type, a method name, and a list of parameters. Methods and members of an abstract class can be defined with any visibility, such as public, protected, private, etc. So in our example, vehicle is an abstract class that contains only one abstract method. Get max speed, right? Remember, it's got no body. Because the implementation of this method is provided by the car and motorcycle classes. You were wondering why that was empty, huh? No body. So the car and motorcycle classes have to override the abstract getMaxSpeed method of the superclass vehicle. Okay, so I heard a couple of pennies drop. So let's do some examples and we can understand the abstract class a little better. So in the Object-Oriented Programming project, right-click on the source folder and select New Class. Specify the package name as Abstract Class and the class name as Vehicle, and choose Abstract to create the abstract class. The vehicle class is an abstract superclass. So let's declare two instance variables that are named type and model with the string type in vehicle class. So let's declare a public constructor that's named vehicle, and it contains two parameters, type and model. Now in the constructor method, we can assign a parameter variable, type, to the variable type of this class. And then we assign parameter variable model to the variable model of this class. And now we can use the this keyword to access the same class variables. Now let's declare two non-abstract void methods in the vehicle class. First one is public void start. And then we print the message vehicle has started by using our print method. So the second one is public void stop. And then we print the message vehicle has stopped by using the print method. Now we can declare an abstract int method that's named getMaxSpeed with no body. And now we must implement this method in the subclass. And here's where you remember to save the code. Okay, so now we're ready to create a new subclass. So just right-click on the abstract class package and select New Class. And then specify the class name as car. Now our subclass car extends the abstract superclass vehicle. So this means that the subclass car inherits all the methods and variables from the superclass vehicle. But wait, we get a compilation error. So what do? We just place the mouse on the car class and Eclipse shows us the quick fix dialog. So we defined a constructor in the abstract superclass vehicle. So that means we must define an explicit constructor in the subclass car. And we must invoke a superclass constructor from this constructor by using the super keyword. So we can add the constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. And look at that. Eclipse auto-magically added the constructor with the super keyword. Now also, if you go back and place the mouse pointer on the car class, Eclipse will show us this quick fix dialog. So we must implement the abstract method getMaxSpeed in the car class. So we select the Add Unimplemented Methods, and then Eclipse automatically added getMaxSpeed as a method with the override annotation. So let me give you a little bit of history. Way back in Java 5, annotations were introduced. So an annotation always starts with the @ symbol, followed by the annotation name. So whenever you override a method of a superclass, it's always best practice to include the override annotation. The override annotation is also used for making code readable as well as avoiding any maintenance issues down the line. So now that we're having fun, let's override some other methods of the superclass vehicle. Now there's no obligation to override non-abstract methods of abstract superclass vehicle. So let's copy the non-abstract methods of the superclass vehicle, and let's make some changes for implementing properties of the car class. So we use the car has started in the start method instead of vehicle. And we use the car has stopped in the stop method instead of vehicle. So let's add the override notation to these methods. In the getMaxSpeed method, we declare a final variable, max car speed, in uppercase letters and then assign this variable to 320. Now, it really is good to get in the practice to use final variables using all uppercase letters and underscores as a separator. So now we print max speed of car by using the print method. And then return the variable max car speed. Remember to save the code. Now let's create a main test class that's named abstract test in the same package. So in the main method, we create a car object by passing parameters. The first parameter, car, represents the type of car. The second parameter, Ferrari, represents the model of the car. Now let's call the overridden start and stop methods from the subclass car. And let's call the overridden abstract getMaxSpeed method from the subclass car. Okay, so let's run the code. And you can see the results right here in the console. Overridden start method was invoked, and car has started is the message that we see displayed. And then the overridden stop method was invoked, and the car has stopped message was displayed. And then the overridden abstract getMaxSpeed method was invoked, and the max speed of car is 320 message was displayed. Interfaces. Interfaces are a set of common behaviors that are implemented by multiple classes. Interfaces can only have constants and methods without a body. So the interface really can't do anything, it's just a pattern. You cannot instantiate an interface, so it means that you cannot create the object of it. An interface does not contain any constructors. An interface is not extended by a class. It is implemented, however, by one or more classes. A class can implement multiple interfaces. So basically, an interface simply is saying, I can do these things, right? So we give a promise to the compiler, so to speak. So in our example, we first define drivable as the interface. So this interface has two methods that are named turn left and turn right with no body, right? Car and motorcycle are the classes that implement this interface. So it means that both of the classes can turn left and can turn right. So the turn left and turn right methods, they must be implemented in the car and motorcycle classes. It's an absolute obligation. All right, so I think that's pretty clear. Why don't we do up some examples with an interface? So go back to the object-oriented programming project, right-click on the source folder and select New Interface, and specify a package name. So let's call it Interface Class. And then the interface name, Drivable. So an interface only declares method names without a body. So we must implement all methods of interface. So let's declare two void methods with no body in the drivable interface. So the first method is turn left, and the second method is turn right. Remember to save the code. Okay, so let's create a new subclass. So right-click on the Interface Class package and select New Class. Specify the class name as car. Now we can add implements as a keyword after the class definition of car. car implements drivable, means that turn left and turn right are the methods in the drivable interface, and they must be implemented in the car class. But hold on, you say, we get a compilation error. So let's hover the mouse pointer on the car class, and Eclipse shows us a quick fix dialog. Okay, so we must implement an abstract method turn left and turn right in the car class. Okay then. So then we select Add Unimplemented Methods, and then Eclipse automatically adds these methods with the override annotation. You thought I was losing my mind. So let's fill the rest of these methods. In the turn left method, we print car can turn left as a message by using the print method. In the turn right method, we print car can turn right as our message by using the print method, and we save the code. Okay, so now let's create a new subclass. Just right-click on the interface class package and specify the class name as motorcycle. And we add the elements keyword after the class definition of motorcycle. So motorcycle implements drivable, means that turn left and turn right are the methods in the drivable interface that must be implemented in the motorcycle class. And now we select the Add Unimplemented Methods to add the methods of interface with the override annotation. All right, so let's fill in these methods just like we did in the car class. In the turn left method, we print motorcycle can turn left for our message by using the print method. And in the turn right method, we print the motorcycle can turn right message by using the print method. And remember to save the code. Now let's create a main test class that's named Interface Test in the same package. So in the main method, first we create a car object. So let's call the overridden method turn left and turn right from the class car. Secondly, we create a motorcycle object. And then let's call the overridden method turn left and turn right from the class motorcycle. Okay, are you ready? Let's run the code. And look at that. You see the results right there in the console. The car can turn left and the car can turn right. The motorcycle can turn left and the motorcycle can turn right. See, autonomous vehicles are very easy to program. That's just a joke. Polymorphism. So polymorphism, because I promised I'd tell you about it, is used to perform a single action, but in different forms. So in Java, we have two types of polymorphism. The first one is static, and the second one is dynamic. So method overloading is an example of static polymorphism. Method overriding is an example of dynamic polymorphism. So in the slide here, you can see dynamic polymorphism. So for example, we have a vehicle superclass, and it has an accelerate method. And we have two subclasses that override the accelerate method of the superclass vehicle. And accelerate works for any type of vehicle, right? Not only a car, but also a motorcycle. The accelerate action is done different in a different form in the car and motorcycle classes. So when we create an object of the subclass and then assign it to the superclass reference, if we call the overridden accelerate method on the superclass vehicle reference, then the overridden method of the subclass will be called. So let's say if we want to create two objects, vehicle equals new car. Now that's a statement that works because car is a subclass of vehicle. Okay? So here the reference variable, vehicle, declared the type of vehicle is pointing to an object of the car class. So in the same way, vehicle 1 equals new motorcycle. That works as a statement because motorcycle is a subclass of vehicle as well. So here the reference variable vehicle 1 is declared type vehicle is pointing to an object of the motorcycle class. And this very useful feature of Java is named polymorphism. So now to bring it home, let's do up some great examples so that we can understand polymorphism in all of its flavors. So we implemented static polymorphism that includes the method overloading in the method section. So we will implement dynamic polymorphism that includes the method overriding in this exercise. Okay? So go back to the object-oriented programming project, right-click on the source folder and select New Class. Specify the package name as Polymorphism and the class name as Vehicle. And the vehicle is our superclass. So now let's declare a public void method that's named accelerate in this class. And then we print vehicle is accelerating for the message using the print method. And remember to save the code. Okay, so let's create a new subclass. So just right-click on the same package and then select New Class. And then specify the class name as car. So our subclass car extends the superclass vehicle. And this means that the subclass car inherits the accelerate method from the superclass vehicle, right? So now let's override this method. We can start with the override annotation, but it's not mandatory here. We'll write accelerate as the method again to override. Now in this method, we can print car is accelerating for a message, and we save the code. Okay, so now let's create a new subclass. So right-click on the same package and select New Class. Specify the class name as Motorcycle. And our subclass Motorcycle extends the superclass Vehicle. So now we write the accelerate method to override by adding the override annotation. And then in this method, we print the message motorcycle is accelerating, and then we save the code. Okay, so let's create a main test class that's named test in the same package. In the main method, first, create a vehicle object reference by pointing to the car class. And this code works because car is a subclass of vehicle, right? So the class vehicle is extended by the class car, and its method accelerate is overridden in the class car. So in this definition, the reference variable vehicle is pointing to an object of the car class. So if we call the accelerate method, it will print the car is accelerating message. You don't believe me? Let's run the code. And you can see it right here in the console. Car is accelerating is the message you see here displayed. So second, let's create a Vehicle 1 object reference by pointing to the motorcycle class. So in this definition, the reference variable Vehicle 1 is pointing to an object of the motorcycle class. So now if we call the accelerate method, it will print the motorcycle is accelerating message. Okay, so let's run the code again. And look at that, you see in the console, the motorcycle is accelerating message. What are the odds? Encapsulation. Encapsulation is one of the fundamental principles in object-oriented programming, and it's used to restrict visibility of the class members to the others. So in our example, we have vehicle class, and we define the model and the max speed variables as a private modifier. Now, if you define a variable or method with the private modifier, you can access these components from the current class only. So, we have only one way to interact with class properties, and that is through its public methods. That makes sense. Now, we define the public setter and getter methods of the max speed variable, so it can be accessed from outside the class. But we have no public setter and getter methods of the model variable, so it can't be accessed from outside the class. So why don't I show you some examples, and it'll help you to understand encapsulation. So in the Object-Oriented Programming project, just right-click on the source folder and then select New, Class, and specify the package name as Encapsulation and the class name as Vehicle. Vehicle class is a superclass. So let's declare two instance private variables that are named model with a string type and max speed with an int type in vehicle class. Now, private means that these variables are visible to the current class only. So now let's declare a public constructor that's named vehicle, and let's assign two parameters, model and max speed. So in the constructor method, we assign a parameter variable model to the variable model of this class. And now we assign a parameter variable max speed to the variable max speed of this class. And now we use the this keyword to access same class variables. Okay, so now let's generate the public getter and setter method of the variable max speed to access from the outside. Now, in order to generate getter and setter methods, we just right-click on the file and then select Source, Generate Getters and Setters. And we'll choose the variable max speed and then click on the Generate button. So all selected getter and setter methods of the variable max speed are generated automatically. Now, we don't want to generate getter and setter methods of the variable model now, because what we'll do is we'll test it in the main method. Okay? Okay, so let's save the code. Now, let's create a new subclass. Just right-click on the same package and then select New Class. Specify the class name as car. And our subclass car extends the superclass vehicle. And what's this? We got a compilation error. So just Hover your mouse on the car class, and what happens? Eclipse shows us a quick fix dialog. And then we define a constructor in the superclass vehicle. So we must define an explicit constructor in the subclass car. And we must invoke the superclass constructor from this constructor by using the super keyword. And now we can add the constructor by selecting Add Constructor in a quick fix dialog of Eclipse. And then Eclipse automatically added the constructor with the super keyword. All right, so in the class car, let's declare a private variable is automatic with a Boolean type. So that means its initial value is false. And now we add the variable is automatic to the constructor of the car class as a third parameter. And then we assign the parameter variable is automatic to the variable is automatic of this class. Now we don't want to generate getter and setter methods of the variable is automatic now because we're going to test it in the main method. So instead, let's create a main test class that's named Encapsulation Test in the same package. So in the main method, we create a car object by passing parameters. The first parameter, Ferrari, represents the model of car. Second parameter, 320, represents the max speed of the car. And the last parameter, true, represents is automatic of that car. And now we can print the properties of the car class by using our print methods. So in the first print method, we display the model of the car. And then we try to invoke the getModel method from the superclass vehicle. But we cannot access this method because we have no public getter method available of the variable model in the vehicle class. So let's open the vehicle class and generate getter and setter methods of the variable model in the same way. Okay, so Eclipse has added public getter and setter methods of the variable model. So we'll save that code. And now let's open the main class again. And let's try to invoke the getModel method. Okay, so we can access this method. And now in the second print method, we display the max speed of car and invoke the getMaxSpeed method from the superclass variable. So we can access this method because we defined the getter method in the vehicle class. Make sense? So in the last print method, we'll display is car automatic or not, and we invoke the isAutomatic method from the subclass car. Oh, but we cannot access this method because we have no public getter method available of the variable isAutomatic in the car class. So let's open the car class, and here's where we generate the getter and setter methods of the variable isAutomatic the same way we did before. Okay, so Eclipse added the public getter and setter method of the variable isAutomatic. Remember to save that code. So let's open the main class again. Let's try to invoke the isAutomatic method. All right, so we can access this method. So now let's go and run the test code. And here you see the results right here in the console. Model is Ferrari, and max speed is 320. So these properties come from the getter methods in the superclass vehicle. But car is automatic is true. This property comes from the getter method of the subclass car.